So this is not true. Why is this not true? Let's do it. We're going to draw a couple of pictures here and think about it. Why is this not true? And then make sure that you don't ever do this, because we're going to do a day on developing actual formulas. So we've got these big formulas, or we will by the end of today, to handle something like that. So it's not as simple as just pulling the 2 out. Like, well, I don't know that's a factor or something. People are factoring it out of the angle. I don't know. But if you really think about it, it makes absolutely no sense on a lot of levels. So here we go. Before we get to that, think about the graphs. Again, when we did equivalent expressions, there's sort of a formula way of doing them, an easy way of doing them, but the homework and I, during the lesson and sort of afterwards, really encouraged you to think about the transformations. Trig is this thing where we understand it on, like, in all different ways, like the unit circle and transformations and the ratio, SOHCAHTOA, or Kixotics, all these different ideas help us with our overall understanding of it. And once that clicks, all of a sudden, you've got all these different ways of solving problems. And so if one way is not working, you can just easily switch to another way and get your answer quickly often. So if I look at this and I think, well, if I was graphing both of those, if I thought of them, like this would be, if this was true, this would be an identity. And it would always be true for all values of theta. And so the graphs would be identical, right? That's what it means. Is that the graph of sine 2 theta would have to be equal to the graph of 2 sine theta. What is the graph of sine 2 theta? It's a horizontal compression by a factor of 2. It changes the period. Do you agree with that? Does that make sense? That's super easy. You guys are awesome at that now. What is 2 sine theta? Change in amplitude. How many people in here believe a change in amplitude or a vertical stretch is the same as a change in period? Oh, gosh, like there couldn't be anything more different, right? It's so different. So how could this possibly be correct? And it would be the same for cos. So there's the graph of, so the orange graph is sine 2 theta or sine 2x, right? It's got to change, the scale is a bit off, but because I didn't rearrange the scale for radians, but you can see that here's one, so this is sine, so there's one revolution, or one cycle, okay? And so it's been compressed to pi, just past 3. And here's 2 sine theta. It's got a period of 2 pi still, so over 6. And it is got to change in amplitude, right? So there's sine, and then if I look at cosine, there it is, right? So again, the green one is cos 2 theta, and the blue one is 2 cos theta, not the same graph. They are true, it's true, they're equal in a couple of places, or if you keep going through the cycle, infinite places, but in one cycle, a couple of places, but that's it, right? So they do meet there. So there is a value where they're equal, but they're certainly not equal everywhere. And same thing for sine. There's a value here. They're equal in a couple of places throughout a cycle, but not everywhere. Okay, so let's just draw that so that we know for sure 100%. So sine would go like that, and then the other one would go like that. Whoops, that's wrong. It would go like that, and then like that, and then like that. It would be like bigger. So the blue one is 2 sine theta, and the red one is sine 2 theta. And then you could do the same thing for cos. Not true. You can always tell when it's a common mistake. Teachers make a big deal out of it and kind of talk about it and like, hello, everybody, pay attention to me. This is a common mistake. So let's figure out what is true. Use compound angle formulas to determine formulas for double angles. So like 2 theta, and I'm going to let you try this. But it's not like yesterday or the day before where it's actually tricky and you'd never kind of be able to figure it out yourself, or it would maybe take you hours. This is actually pretty easy. We're going to use the compound angle formula. How would I use the compound angle formula? We'll do this part together, then I want you to just try a little bit of it on your own. How would I use a compound angle formula to come up with a formula for 2 theta? Sine of 2 theta. So sine of a plus b or sine of a minus b, how would I use that? Come up with sine of 2 theta. Anybody got an idea? Vivian. Nice, theta plus theta. Okay, so we start with that. This is going to be sine of theta plus theta. Go. If you end up getting it wrong, don't worry, because you can scratch it all out and write down the correct answer, and then if you want to copy down the proper proof. This one's really easy. So just sub it into the formula. If you're the type who's hesitant to do this kind of thing, like I see some of you not doing it, you're waiting, but like, no, come on, try it. Like that part of learning is risk. You gotta take a risk, you gotta put yourself out there a little bit. Just try. What's the worst that can happen? You wasted a little bit of lead in your pencil. Scratch it out and write down the right answer after try. It says people always struggle, like, oh, I'm always at a 70 or I'm always at an 80 and I want to push myself up. That's how you do it. Take a little bit of risk, push yourself a little bit, do something you wouldn't normally do. Okay, so what's the formula for compound angle for sine? Sine A plus B? Chad? Right, so sine A cos A, but it's like theta. They're both theta. So sine theta cos theta plus cos theta sine theta. So if it was A plus B, those would be like flipping. It'd be the A and the B and then the B and the A, but they're both the same. So what is this? I have sine times cos plus sine times cos, just out of order. This is like xy plus yx, which is xy plus xy, which is? Nathan, what is it? 2xy, or 2 sine theta cos theta. Those are the same thing, common. They're like terms. If I add them together, I have 2 of them. 2 of the same thing. Formula. Done. Sine 2 theta equals 2 sine theta cos theta. If you look back at what we would have guessed it was, sine 2 theta equals 2 sine theta, we were actually close. We're just missing something. Okay? Pretty good with that? Okay, let's do cos. So we start with cos of theta plus theta. So I want you to do the first part. What's the formula for cos of a double angle, or sorry, not a double angle, a compound angle? Brandon. Okay, so cos A or cos theta, because A and B are the same. And I said plus. This is one where you change the sign, right? So it should be minus. And then sine theta. What's cos theta? Say that again, Vivian. Yeah, cos squared theta minus sine squared theta. And formula. Now, sorry about this. I didn't make this up, but yes. Good thought. So, first of all, anybody thinking like, oh, hey, I recognize that Pythagorean identity. This is not, whoops, I'm going to use a different color for that. This is not equal to 1. It is also not equal to -1. Don't start making stuff up. Cos squared theta plus sine squared theta is equal to 1. Cos squared theta minus sine squared theta is not. Okay, so it's equal to cos 2 theta, apparently, right? So it's not 1, and I know that's not what you were saying, and it's not -1. So what Sam says is interesting. Can't we simplify it further? I don't know, like, is it going to be simpler? I don't know. That's a tricky thing. Like, what at this point, define what simpler means. Will it be more convenient? Sometimes to take this further. So we're going to do that. So this is what I was starting to say. Sorry about this. It's not so easy. We're not done. This is a formula. Okay? But there's a whole bunch more of them. So what Sam was saying is we can substitute. One of the identities we do have is sine squared theta plus cos squared theta is 1. And if I want to rearrange this for cos squared theta, I would get cos squared theta. We know this. We've seen this equals 1 minus sine squared theta. So I can sub that in for cos squared theta, and I get 1 minus sine squared theta minus sine squared theta, which equals 1 minus 2 sine squared theta. And formula. Okay? Or I could do this. Equals cos squared theta minus, and in the same vein, sine squared theta is equal to 1 minus cos squared theta. So 1 minus cos squared theta. Distributing the negative is cos squared theta minus 1 plus cos squared theta, which equals 2 cos squared theta minus 1, and formula. And so, is it simpler? I don't know. Like, it's kind of 6 of one, half a dozen of the other. Like, it's really not about being simpler. It's about sometimes we like this one, sometimes we like that one, sometimes we like that one. Entirely depends on what we're doing. Okay? So you do need to know all three. And I admit this is a bit tricky. I mean, they're not big formulas, but you just learned 6 in the last 2 days that are all kind of similar. So they're not really hard. But again, that is a lot. And this one can be confusing because it's a lot like an identity. And these two can be confusing because one is 1 minus 2 sine squared theta. The other one is 2 cos squared theta minus 1. Getting those backwards or mixed up is obviously not going to work. You can't flip them, right? It's got to be 1 minus sine and cos minus 1. So you got to sort of just work with it and try to get them. Remember that cheat sheet thing that I talked about doing? Add all of these to your sheet. Try to have it all in one place. It'll help you as you're working through the homework, and it'll help you memorize all of this and get through it all. And I mean, deriving these formulas didn't take a lot of work. There's not a lot to that. I'm not suggesting you rederive all the formulas on a test, but you could possibly work through the logic and be like, okay, which one would be minus and which one would be -1? And like, you might be able to kind of figure that out. And you know that it's not the Pythagorean identity, so it's similar, but it's just with a minus sign? I don't know. Okay, so try to come up with a way that you can memorize these guys too. Okay? Questions? Oh, we're not done yet. What about tan 2 theta? So this is like tan theta plus theta. So you can do this one as well. No tricks to this one. You got to get the formula right, but two tan theta over 1 minus tan squared theta. Okay. Very good. Any questions? And formula. Okay, let's take a look at a couple of examples. This is one that pops up in the textbook. If sine theta equals negative 2 over 5, find cos 2 theta and sine 2 theta. I'm going to change this to pi by 2 to pi. So we're going to just go in the second. I'm going to tell you what quadrant it's in. Wait, that doesn't make any sense. Oh, no, it doesn't. From pi to 3 pi by 2, how about? Because the textbook does this, it does make your life a little bit easier. If it was like all the way to 2 pi, then you'd have to consider multiple answers, but which that wouldn't be. It'd just be a little bit of extra writing, a little bit of extra work. It wouldn't be too hard. Okay, but the textbook does narrow it down. So we're in quadrant 3. Let's just say that. Okay, where sine is negative. So here's how I would start a question like this. So this to me, like the first part of this is Sir Kicks or Ticks. Sir Kicks or Ticks. So if sine is negative 2 over 5, sine is y over r, so y is negative 2. Because r can never be negative, so if it's in quadrant 3, so that makes sense as well, right? That fits, but I could just deduce that. And r is 5. How do I find x? Pythagorean theorem. X is 5 squared minus 2 squared. Which is the square root of 21. And it's in quadrant 3, so it's negative. It's like plus minus square root of 21, but we're in quadrant 3, so we know it's negative. Okay? Everybody okay with that? And so that means, I already got sine theta. I don't need to rewrite it, but I'm just going to do it for completion's sake. Sine is negative 2 over 5. Cos theta is x over r, so negative root 21 over 5. And tan theta, which we don't need, but if we did, would be y over x. They're both negative, so it's positive. So it would be positive 2 over root 21. If I do that little bit of pre-work, it's going to make some of the rest of this kind of easier. So let's find cos 2 theta. We got 3 possible formulas for cos 2 theta. Which one would we use? I don't think it matters much in this case. I'm going to use the first one. Cos squared theta minus sine squared theta. And cos theta is negative root 21 over 5. So it's negative root 21 over 5 squared minus sine squared theta, which is negative 2 over 5 squared. So that's 21 over 25 minus 4 over 25, which is 17 over 25. Is that all right? Do you follow how, like, why we had to do that first little bit? Come up with your y, come up with your x, come up with your r, like break it down into those 3 parts so that I can come up with an expression for, I already had sine theta, but cos theta, and if you need it, tan theta. Because when I take my double angle formula and I use it, I have all it's all cos thetas and sine thetas and tan thetas. It's not tan 2 theta anymore, so I need those values. Okay, good. And then sine of 2 theta is 2 sine theta cos theta. So it's 2 times negative 2 over 5 times negative root 21 over 5. So that looks like 4 root 21 over 25. I think the questions in the textbook are a little bit nicer. They don't have a radical. I think they work out. They're like what we call Pythagorean triplets. 3, 4, 5, that kind of thing. Everybody okay with this? And there's a whole part of the homework where it's like, it just gets you to kind of rewrite stuff. There's actually not a lot of manipulation. There's a little bit, but some of it is just rewriting with formula. It's kind of weird. It's kind of easy. Okay, so one more example for fun, because this one is super fun. Use a double angle formula to determine the value of cos pi by 3. We can do, that's a special angle. We can do, in a special triangle, we can do that. We know what cos of pi by 3 is. This wants us to use a double angle formula. So how would we do that? So this is like cos 2 theta. How would we do this? Any ideas? Vivian. So what would that give me? Pi by 6. 2 times pi by 6 is pi by 3. So if I use pi by 6, I mean, you could kind of show this. This is not a thing that you have to do. It works. Nothing wrong with it. If I want cos of 2 theta to equal cos of pi by 3, if I took, we call this the arc cos or the inverse cos, so cos negative 1, right, the shift cos thing, then I would get, on both sides, I would get this. So just like Vivian said, divide both sides by 2, and theta is pi by 6. So let's do it. Cos of 2 times pi by 6. We're not going to simplify that. We're going to use our formulas. Let's use the first one. Is cos squared theta minus sine squared theta. So that's cos squared pi by 6. That's our theta. And it's 2 times that, but we want theta when we move into the actual formula. Not 2 times theta, theta. See what I'm saying? I think some people would put pi by 3 in there. Be like, oh, 2 times pi by 6 is pi by 3. So they'd put pi by 3 in there. But that's not what we want. We want that. Minus sine squared of pi by 6. What is cos of pi by 6? Root 3 over 2 all squared minus, what is sine of pi by 6? Kevin, what's sine of pi by 6? 1 over 2 all squared. So 3 over 2 squared is not 9. Nope, it's 3, sorry. Over 4 minus 1 over 4, which is 2 over 4, which is a half, which is cos of pi by 3. Is it not? Yes, it is. Beautiful. Or, what if we did this? Let's use one of our other 2 formulas. 1 minus 2 sine squared theta. 1 minus 2 sine squared theta, which is 1 minus 2 sine squared pi by 6, which is 1 minus 2 pi by 6. Sine of pi by 6 we've already done, right? It's a half. So a half squared, which is 1 minus 2 times 1 over 4. Those cancel. I'm left with 1/2. 1 minus 1/2 is 1/2. Yes. Yes. Or could we do the other one? 2 cos squared theta minus 1. Okay, go for it. Try this one on your own. Remember, we already did the cos of pi by 6. That is a nice thing about this. Once you've done sort of part of the question, you usually kind of have a thinking part done and just sub it in, rearranging and solving. That's what I love about math. It works every time. Like, how does it work every time? Why does it just always work? Shouldn't there be something that doesn't work? Everything else in the world has that. Nothing else is certain in life except math. 2. So, cos, I got to sub this in. So, 2 cos squared pi by 6 minus 1, 2 root 3 over 2 squared minus 1, 2, 3 over 4 minus 1. So then again, these are gone. And I get 3 over 2 minus 2 over 2. Oh my gosh, look at that. Yes. Beautiful. Any questions?